23rd question. Question number 23rd. Okay. 23rd question. The half-life of a radioactive substance is 30 minutes. The time taken between 40% decay and 85% decay of the same radioactive substance. Huh? Okay, listen here. So, half-life of radioactive substance is 30 minutes. So, T is 30 minutes, right? Suppose there are 100 nuclei, right? So, in this 50% decayed, correct? 50% decayed. How much time taken? 30 minutes, correct? Now 50% of this, how much is this? 25%. Leftover is 25% now. If 100% is there, for decaying 50%, it is 30 minutes. Now 50% of this is 25%, again 30 minutes, correct? So next is they are asking 40% decay and 85%. Now next will be what? 12.5%. 12.5% decay. It again takes 30 minutes. Correct? But I'll tell you 40% to 85%. So this becomes how much here? How much decayed here? 87.5. Correct na? So at this point 87.5% has been decayed. Yes or no? Ardada? ಅರ್ಥ ಆಯ್ತಾ ಹೇಳಿದ್ದು 100% ಇದ್ದಾಗ ಅದರಲ್ಲಿ 50% ಡಿಕೆ ಆಗೋಕ್ಕೆ 30 ಮಿನಿಟ್ಸ್ ತಗೊಳುತ್ತೆ. ನೆಕ್ಸ್ಟ್ 50% of this is 25, 30 minutes, and next 50% of this is 12.5. What is left is 12.5%. How much has been decayed? 87.5. But they are asking here, question here is 40% somewhere here to 80%, not 87, it is 80%. 85%, sorry, 85%, right? So it is roughly about 30 minutes, and again 30 minutes is there now. So here 30 minutes from 40% you take. 40 to 85%. So there is some time is there now. Okay, 10 here. Okay, 52, then 80%. So this is 30 minutes, and is roughly about. Okay. So 85% they are saying, 85% andre roughly you can take it as 20 minutes. Okay, and here about 10 minutes. Therefore answer is 60. Artha aita? It's almost equivalent of 2 half-lives. One half-life is 30 minutes na. So it is almost equivalent of 2 half-lives. So therefore it is 60 minutes. Artha aita ellargu idu? Nuclei most likely kelanತ question ತುಂಬಾ ಈಸಿ ಇರುತ್ತೆ. Either about this half-lives ಬಗ್ಗೆ ಕೇಳ್ತಾರೆ ಅಥವಾ radioactivity ಬಗ್ಗೆ ಕೇಳ್ತಾರೆ, ಇಲ್ಲ previous we discussed radius or anything about binding energy, mass effect ಕೇಳ್ತಾರೆ. Easy questions ಇರುತ್ತೆ. So just have to understand and answer. It will not take much time. Not like what we have done numericals previously. It will not take that much time. Just understand the concept and answer it. Okay, next. So next question. A nucleus of uranium decays at rest into nuclei of thorium and helium. Then a nucleus of uranium decays at rest into nucleus of thorium. So uranium 235, correct na? So it's thorium. Thorium is 90 na? And thorium and helium. Helium is 2He4. So thorium and helium. Then the helium nucleus has more momentum than thorium nucleus. The helium nucleus has less kinetic energy than thorium nucleus. The helium nucleus has more kinetic energy than thorium nucleus. The helium nucleus has less momentum than the thorium nucleus. Which is the correct answer here? Thorium is heavier or helium is heavier? Thorium is heavier. Correct na? Thorium is heavier. So therefore thorium has less kinetic energy compared to helium. So therefore helium nucleus has more kinetic energy. Helium has more It has lesser mass. It has more kinetic energy than the thorium nucleus. So we cannot say anything about momentum. Momentum and takshana direction barutte. We cannot say momentum. We can say kinetic energy. So it will have more velocity. Are you clear? So next question. Per nucleon of lithium. In ಮಾಡ್ತೀರಾ ನೀವು? Try to solve this question. Solve this question. Binding energy per nucleon. Will you be able to solve this? Try it now. Nucleons are there? 4 here, 4 here now. 8 nucleons. 4 under 2 protons, 2 neutrons. Here also 2 protons, 2 neutrons. Here 7 nucleons, 3 protons and 4 neutrons. So therefore 7 into 5.60 minus 7.06 into it is 8. How much is this? $39 hai though. Correct? 39.20 minus, how about this? 56 ಎಷ್ಟಾಯಿತು? 56.48, 39.20. 9 is 7. 17.28. So roughly it is option D. Option D, 17.3 MeV. A neutron bombarded with neutron, it generates krypton and 3689. 3 neutrons plus 3 neutrons, and which is the other nuclear formed? Which is the other nuclear formed? Which is right here 236 na 92, correct? Left hand side 92, 236, correct now? Right hand side is 90, 93 agutte. So 3 andre idu 3 agutte. So it becomes 92, and here 38. Subtract it now. If you subtract 3 neutrons na, 3 it is 89, 92 and 38. Subtract this, how much you'll get? Option? Option A correct na? Barium. Barium 56, 144. 29th question. 29th question. Certain mass of hydrogen is changed to helium by the process of fusion. Right? What is happening in nuclear, solar radiation? We are getting sunlight due to nuclear fusion, where hydrogen is combining. Okay, hydrogen is combining, right? Hydrogen is combining to form helium nucleus. So there is energy released. So that is what nuclear fusion is happening. So a certain mass of hydrogen is changed to helium by the process of fusion. The mass defect in fusion reaction is mass defect. Delta M kodidare. Delta M is how much? 0.02866 atomic mass unit. The energy liberated per 1 AMU is, what is the energy liberated per AMU? How much is this? So they are given 1 atomic mass unit is equal to 931 MeV, right? So per AMU, so this is the mass liberated, this is the mass defect. Arthaktidyā? Mass defect is so much, right? So per AMU calculate ಮಾಡಬೇಕು. 1 AMU is this. ಏನು ಮಾಡ್ತೀರಾ? .02866 into Correct? This is energy released per AMU. Can you calculate this? How much is this? Huh? So 26.7 MeV. Approximately it is 26.7 MeV. Question number 30. So the power obtained in a reactor using uranium-235 disintegration is 1000 kilowatt. So power obtained in a reactor using uranium-235 disintegration is 1000 kilowatt. The mass decay of uranium-235 per hour. How much mass decayed per hour? Okay. So what do you mean by power? Power means what? Energy released per second. Alva? Energy released per second. So power means 1000 kilowatt, which means that it is 1000 kilo means 10 to the power of 3 joules per second. Ardha 1003 joules. Ardha denrapa. Ardha agtidya. Power andre it is the amount of energy released per second. 1000 kilowatt. Are you understanding? 1000 kilowatt means energy released is 1000 into 10 to the power of 3 joules. Right? So it is how much it is? 10 to the power of 6 joules. 10 to the power of 6 joules. So what do you have to find out here? The mass decay per hour. How much mass decayed per hour? Right? So this is per second. This is energy release per second. So what about per hour? Per hour is how much? Energy release per hour. Huh? Divide ಮಾಡ್ತೀರಾ? Multiply. Energy released per hour is equal to how much? 10 to the power of 6 into. This is per second. Hour means 60 into 60. So it is 36 into 10 to the power of 8 joules. Correct? That is the energy released. Okay. Wait. ಇದು ಅರ್ಥ ಆಯ್ತೇನ್ರಪ್ಪ ಇದು? So this is energy released. This is energy released per second. Now we have to find out mass decayed. Mass decayed is how much? But here, so ಅದೊಂದು ಇನ್ಫಾರ್ಮೇಶನ್ ಕೊಟ್ಟಿಲ್ಲ ಇಲ್ಲಿ. ಓಕೆ, ಏನಂದ್ರೆ ಒಂದು ಆಟಮ್, if one atom of uranium decays, what is the energy released? $200 MeV, no? Fission. It's a fission now here. Fission. Okay. Honestly, this information they will not give. Will I do? Okay. Approximately 200 MeV. So to be precise, it is 208 MeV. So if one atom of uranium undergoes, okay, 200 MeV of energy is released. So to get this much of energy, so how many atoms? Calculate that now. If this much of energy has to be released, what is the number of atoms that should be decayed? So if one atom one atom of uranium-235 undergoes decay or disintegration, so this is the amount of energy released. So if you want to have this much of energy, the how many atoms have to be disintegrated or decayed? Artha aita? So for 200 MeV, so if one atom, or you can write it as 200 MeV, so one atom, okay, therefore 36 into 10 to the power of 8 joules, how many atoms will be decayed? So basically it is 36 into 10 to the power of 8 joules by 200 MeV. So MeV is 10 to the power of 6. Okay, electron volt to joules is 6 into 10 to the power of 19. You get number of atoms here. So number of atoms decayed. Artha ಹೇಳಿದ್ದು? You get number of atoms decayed. And again here we know that Avogadro's hypothesis 6.023 into 10 to the power 23 atoms is equal to how much? Atomic weight 235. ಅದು ಮಾಡಬೇಕಾಗುತ್ತೆ. ಇದು ಬಂದ ಮೇಲೆ next okay, you get the number of atoms. Once you get the atoms, you should know that 235 grams has 6.023 into 10 to the power 23 atoms. So this number of atoms is equal to how many grams? That you have to calculate. ಮಾಡ್ಕೊಂತೀರಾ ಇದನ್ನ? Okay, right. I'll stop at this point. So we'll continue in the next class because reaction takes place at high temperature because option number C, kinetic energy is high enough to overcome the Coulomb repulsion between the nuclei. Okay, right. So last chapter of second PU, right? And next we'll have first PU later. Okay. Namaste. Namaste. Okay. So listen here. Semiconductors. Semi means the conductivity lies between the conductors and insulators. Conductors and insulators. So therefore they are called semiconductors. They are called semiconductors. So their conductivity and resistivity. Conductivity and resistivity. So resistivity and conductivity are reciprocal, right? So it lies between the conductors and insulators. So therefore they are called semiconductors. So when we talk about the resistivity, it lies between 10 to the power minus 6 to 10 to the power of 4 ohm meter. So this is for semiconductors. You can take minus 8 or minus 6 or minus 4. So the resistivity, resistivity lies between 10 to the power minus 6 to 10 to the power of 4 ohm meter, and this is for semiconductors. And for conductors it is about 10 to the power minus ohm meter. So that is what, whereas insulators is very high. Insulators, the resistivity is very high, right? So that is how basis the resistivity. So we have classified conductors, semiconductors and insulators. And there is one more difference. You would have studied energy gap, right? So conduction band, valence band. So valence band, the energy corresponding to the electrons which are in the valence band, that's called valence band, right? Conduction band, valence band is superposed. There is no gap between the valence band and conduction band. So this is for conductors. And if I take semiconductors, there is an energy gap which is very small, which is about 0.3 electron volt, correct now? 0.3 electron volt. And if I take insulators, which is very high, it's about 0.81 electron volt, right? So energy gap is more for insulators. So therefore, and one more difference here is that in metals, the electrons, since it's carry current, they carry charges, electrons. But in semiconductors, at 0 Kelvin, if I take at 0 Kelvin or at 0 degree Celsius, the conductors are insulators because there is a gap. They cannot go to conduction band. They are in valence band, but they cannot go to conduction band because they need some energy. So as the room temperature, so as they come to the room temperature, they become conductors, right? They have sufficient energy to go to the conduction band. ಅರ್ಥ ಹೇಳಿದ್ದು ಇನ್ಸುಲೇಟರ್ಸ್ ಹಂಗಲ್ಲ, ಎನರ್ಜಿ ಗ್ಯಾಪ್ ಜಾಸ್ತಿ ಇರುತ್ತೆ. So they need lot of energy, right, to go to the, and as such there are no electrons in the conduction band, right? All of them have 4 electrons, but carbon and germanium are, sorry, silicon and germanium are semiconductors, where carbon is the insulator because depends on orbit, whereas those 4 electrons in germanium or silicon, they are in the outermost orbit, right? Whereas in carbon they are in the second orbit. So that's the difference. So like that, so difference between carbon and, so they have the 4 electrons in the outermost orbit, but carbon is the insulator, germanium silicon is a semiconductor. So this is how the difference between conductors and semiconductors. And now we know that pure semiconductors, which are called intrinsic semiconductors. These are called intrinsic semiconductors. So pure semiconductors, if I take germanium and silicon, so germanium has 4 electrons, right? So it shares 1 electron with 1 germanium of neighboring atom, correct now? So all 4 electrons are, right, they made a bonding with neighboring germanium, 4 electrons are there. Now suppose if temperature increases, now this is a insulator, 0 Kelvin insulator, no electrons are available, correct now? So therefore it's an insulator. Now if temperature is increased, the electrons gain energy, they come out of the bonding. Now once electron comes, one hole is created here. Hole is nothing but equivalent of, the charge is equivalent of negative charge, electron, but it is positive charge. Hole means it is equivalent of 1 positive charge. Artha aita helidu? So 1 electron is liberated, 1 hole is created. Hole is equivalent of positive charge here. They also carry charges. Holes can accept electrons here. So hole is equivalent of negative charge, but it is positive. So therefore at room temperature, so number of electrons is equal to number of holes. So that is called a pure semiconductor, intrinsic semiconductor. So number of electrons and number of holes. And if I take extrinsic semiconductor, so what is extrinsic semiconductor? So dopant is added, right? If I add a travalent like aluminum, okay, if I add like so it makes bonding with aluminum here. So aluminum has 3 electrons, there is 1 hole here. It makes bonding with 3 neighboring germanium atoms, right? 1, 2, 3. It shares 1 electron with germanium atom. It makes the bonding, but there is a hole created. So it can take 1 hole here. It can take 1 electron. So hole is basically, it is an equivalent of electron but positive charge. So it can accept electron here. So yavaga enagutte? So this will pull 1 electron from the neighboring atom. So again hole is created. So this way, in extrinsic semiconductor, this is called a p-type semiconductor. So in p-type semiconductor, if I add 1 aluminum atom, so there was 1 hole created. So this way, depending on number of atoms added to the crystal, germanium crystal or silicon crystal, so we have the number of holes created. So therefore in extrinsic semiconductor, which is basically p-type semiconductor, the number of holes is more than the number of electrons, because it has a creation of hole here. So therefore p-type semiconductor, the majority carriers are holes. And if I talk about pentavalent, like you can add stibbium, okay, which is called antimony, correct now, or phosphorus. So it is pentavalent, phosphorus or stibbium. So when you add, this is a pentavalent, 4 electrons in the outermost orbit. So it makes bonding with 4 neighboring germanium atom. But so if I take phosphorus here, so 1, 2, 3, so it forms bonding with 4 neighboring atoms, but there is 1 electron left, okay. So this electron carries charges, right, this carries current. So therefore if I add 1 phosphorus atom, so 1 electron is created depending on number of atoms added. So we have the electrons in the crystal. So this way, so this is called n-type semiconductor. So in n-type semiconductor, a pentavalent is added to a pure semiconductor, and this is called the n-type semiconductor. Majority charge carriers are electrons, minority carriers are holes. Now so this is about intrinsic and extrinsic semiconductor. Now next comes the diode, semiconductor diode. I will roughly explain this, I will not go in detail. So whatever required here, I will explain just to recapitulate what have we studied. Now so when a p-type and n-type, they are merged, right, when p-type and n-type is merged, right, merging means, right, we add, so we take a pure semiconductor, we add lot of n-type semiconductor to that. Illandre p-type is taken, n-type is taken, some process we merge them. So we have the p here, n here. Now wherever there is a p-type, we have excess number of holes, na, correct, and wherever n-type is there, we have excess number of electrons. Now due to concentration gradient, concentration gradient means more of electrons this side with respect to distance. That is called concentration gradient. More electrons you find in n-type, more holes this side. Now what happens? Diffusion takes place. Diffusion andre how gases move, how clouds move. Clouds ಏನಾಗುತ್ತೆ ಒಂದೊಂದೇ cloud ಹೋಗುತ್ತಾ ಇಲ್ಲ, they go together na, so that is called diffusion. Like how gases, air move, that is called diffusion. So there is a diffusion concentration gradient, electrons will move from this side and holes will move this side. So ಇವಾಗ ಏನಾಗುತ್ತೆ, holes created here, holes travel this side, some of them combine with the electrons, these electrons combines with the holes, there is a formation of neutral atom. So but at certain point ಏನಾಗುತ್ತೆ, so we have, okay, ಇದರಲ್ಲಿ ಏನಾಗುತ್ತೆ, the holes will move this side, so therefore we have something called, okay, generation of junction. ಯಾಕಂದರೆ ಈ ಕಡೆ ಎಲ್ಲ electrons ಈ ಕಡೆ ಹೋದಾಗ, holes ಈ ಕಡೆ ಹೋದಾಗ, there is a junction created where we have the positive this side, right, negative this side. ಅರ್ಥ ಆಯ್ತಾ? ಅರ್ಥ ಆಯ್ತಾ ಹೇಳಿದ್ದು? So there is a barrier created, means there is an electric field here. This is an equivalent of electric field now, the positive field, negative field. So because of motion of electrons this side, so there is a positive field created here and negative field. So you have more negative charges here, more positive charges here, and this barrier is created. This is called a potential barrier. Now once potential barrier is created here, no more holes will move this side, no more electrons will move this side, because electrons, these are repelled by the negative field and holes will be repelled by this. Okay, so that is called potential barrier. Now it could be about, depending on your crystal, silicon or germanium. So we have it varies from 0.3 to 0.7 electron volt, this potential barrier. So you would have done semiconductor diode experiment ಮಾಡಿದ್ರಲ್ವಾ? What is the knee voltage you got? Knee voltage, where the current increases drastically. Initially current 0 irutte, sudden current increase aguttalla. What is the voltage you got? 0.3, 0.4 ಬಂದಿರುತ್ತೆ ಅಥವಾ 0.7 electron volt. 1 point ಬರೋದಿಲ್ಲ, point less than 0.7, 0.8. Okay, sudden ಆಗಿ current increase ಆಗುತ್ತೆ. Slow it will be in milliampere, right? 0, 10 milliampere, sudden ಆಗಿ 80 milliampere ಆಗಿರುತ್ತೆ. So that is called the knee voltage. Now, so this is called knee voltage. Now we'll discuss about forward bias, reverse bias. Now suppose p type is connected to the positive terminal, n type is connected to negative terminal of the battery. Okay, if p type is connected to the positive terminal, n type is connected to negative terminal, it is called forward bias. It is called forward bias. So during forward bias it conducts. ಏನಾಗುತ್ತೆ, if the applied voltage is more than the barrier voltage, the applied voltage is more than the barrier voltage. So if the applied voltage is less than the barrier voltage, ಅದಕ್ಕೆ ನಿಮ್ಗೆ ಕರೆಂಟ್ ಬರೋದಿಲ್ಲ ಇಲ್ಲಿ. If the voltage, input voltage is less than 0.1, 0.2, 0.3 electron volts, there was no current. That's because the barrier voltage, whatever the applied voltage, is less than the barrier voltage. ಅವಾಗ ಏನಾಗುತ್ತೆ, this energy is not enough to break this barrier. ಅರ್ಥ ಆಗ್ತಿದೆಯಾ? There is a wall created, so electron cannot cross over this, right? So ಯಾವಾಗ applied voltage is more than the barrier voltage, as you increase the voltage, like if the barrier voltage is 0.3, 0.4, so you can see that positive field. So ಇದೇನಾಗುತ್ತೆ, now when it is positive field here, it is negative, so direction is negative ಅಲ್ವಾ? So ಅವಾಗ ಏನಾಗುತ್ತೆ, so this will, applied voltage is more than the barrier voltage, then the barrier is broken. So electrons have sufficient energy to, it's like positive field here and negative field. ಅರ್ಥ ಆಯ್ತಾ ಇದು? So this is negative field, negative terminal ಅಂದ್ರೆ negative field ಅಲ್ವಾ ಇಲ್ಲಿ, and here it's positive field. So ಅವಾಗ ಏನಾಗುತ್ತೆ, so these electrons are pulled by the positive field and these holes are pulled by the negative field. So ಅವಾಗ ಏನಾಗುತ್ತೆ, barrier is broken. Okay, so therefore there is a current through the conductor, sorry, diode, p-n junction diode, that's called semiconductor diode. And reverse bias is when, so you connect this, p type is connected to negative terminal, n type is connected to positive terminal. So ಅವಾಗ ಏನಾಗುತ್ತೆ, reverse, here negative field, okay, it doesn't conduct. So the barrier applied voltage, right, so ಅವಾಗ ಏನಾಗುತ್ತೆ ಇದು, it will not conduct, it is in reverse bias. In reverse bias ಏನಾಗುತ್ತೆ, it will not conduct. So therefore no current. So in case current ಅಂತಂದ್ರೆ ಯಾವಾಗ ಏನಾಗುತ್ತೆ, reverse bias voltage like Zener diode is highly doped one. So ಅವಾಗ ಏನಾಗುತ್ತೆ, the barrier is broken, so you will have sudden current in case of Zener diode. Okay, so that is called a forward bias and reverse bias. In forward bias it conducts, and reverse bias it does not conduct. Okay, so that is about the semiconductor diode. And semiconductor diode is used as what? Rectifier. It is used as a rectifier. What is a rectifier? Conversion of AC to DC. So half wave rectifier, only half of the AC input is converted. And full wave rectifier, so how many diodes are used in full wave rectifier? 2 diodes. Okay, 2 diodes, right? So in half wave rectifier only 1 diode is used. Okay, ಮತ್ತೆ ಏನು ಅಂದರೆ ನಿಮಗೆ CET ಪಾರ್ಟ್ಗೆ ಆಂಪ್ಲಿಫೈಯರ್ಸ್ ಇರಲ್ಲ. ಇದರಲ್ಲಿ ಆಂಪ್ಲಿಫೈಯರ್ಸ್ ಕ್ವಶನ್ಸ್ ಕೆಲವಿದೆ, ಯಾಕಂದರೆ ನಿಮ್ಮ ಬೋರ್ಡ್ ಪಾರ್ಟಲ್ಲಿ ಇರಲಿಲ್ಲ. ಟ್ರಾನ್ಸಿಸ್ಟರ್ಸ್ ಇತ್ತಾ? No transistors, right? So we'll not discuss about questions related to that, because transistors is not there in the syllabus. Board syllabus is not there, and therefore it will only be there in CET syllabus. Okay, so ಯಾಕಂದರೆ ಆಂಪ್ಲಿಫೈಯರ್ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಬೇಕು ಅಂದರೆ I need about 4 to 5 classes. Okay, ಅದರಿಂದ ಬೋರ್ಡ್ ಪಾರ್ಟ್, ಯಾಕಂದರೆ ನೀವು ಬೋರ್ಡ್ ಪಾರ್ಟ್ ಓದಿಲ್ವಲ್ಲ, ಟ್ರಾನ್ಸಿಸ್ಟರ್ಸ್ ತುಂಬ ಟೈಮ್ ತಗೊಳುತ್ತೆ. ಆ್ಯಂಡ್ ಆಫ್ಟರ್ ದಟ್ ವಾಟ್ ವಿ ಹ್ಯಾವ್ ಲಾಜಿಕ್ ಗೇಟ್ಸ್. ಅದು ಗೊತ್ತಿದೆಯಾ ಲಾಜಿಕ್ ಗೇಟ್ಸು? Everybody is familiar. Okay, okay, we'll go to the adu concept banದಾಗ explain ಮಾಡ್ತೀನಿ. So we'll go to the questions now. Okay, semiconductors, first question. See, first 4 questions are related to amplifier. Okay, 4 questions ಬಿಡ್ಬಿಡಿ ಅನ್ನ. First 4 questions are related to amplifier. Are you clear? Yes sir. First 4 questions are related to amplifier ಬಗ್ಗೆ ಓದಕ್ಕೆ ಹೋಗಬೇಡಿ. CET ಲ ಆಂಪ್ಲಿಫೈಯರ್ಸ್ ಇರೋದಿಲ್ಲ, ಯಾಕಂದರೆ ಬೋರ್ಡಿಂದ ತೆಗೆದುಬಿಟ್ಟಿದ್ದಾರೆ. ಸೊ therefore it won't be there in CET also. Are you clear? Amplification and basically the input voltage is increased, that's called amplifier. Whatever the input voltage, like you have done in transformers na, transformer, what is the role of transformer? Step up, step down, transformer. So same role plays here, but ಏನಂದ್ರೆ ಅಲ್ಲಿ AC voltage ಇರುತ್ತೆ, ಇಲ್ಲಿ this is a DC voltage. Are you clear? So ನೀಟಿಗಿರುತ್ತೆ, ಟೈಮ್ ತಗೊಳ್ಳೋದು. ಆಂಪ್ಲಿಫೈಯರ್ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಬೇಕು ಅಂದರೆ ಟೇಕ್ ಟೈಮ್. ಓಕೆ, ಸೊ ಬಟ್ ಯು ವಿಲ್ ಹ್ಯಾವ್ ಪ್ರಾಬಲಿ 1 ಕ್ವಶನ್. ಓಕೆ, ಸೊ ಅದರಿಂದ ಆಂಪ್ಲಿಫೈಯರ್ ನಿಮ್ಗೆ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಬೇಕು ಅಂದರೆ ಐ ಹ್ಯಾವ್ ಟು ಎಕ್ಸ್ಪ್ಲೇನ್ ಟ್ರಾನ್ಸಿಸ್ಟರ್ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಬೇಕು. ದೇರ್ ಆರ್ 2 types of ಟ್ರಾನ್ಸಿಸ್ಟರ್. ಬೇಡ ಅಲ್ವಾ? ಓಕೆ, ಅದಕ್ಕೆ ಇಟ್ ಟೇಕ್ಸ್ ಲಾಟ್ ಆಫ್ ಟೈಮ್. ಹೇಳ್ದಂಗೆ ಥಿಯರಿ ಪಾರ್ಟ್ ಅರ್ಥ ಆದ್ರೇ ನಿಮಗೆ ಅರ್ಥ ಆಗೋದು. ಸೊ ಅದಕ್ಕೋಸ್ಕರ let's not worry about. Okay, next we'll go to classification of metals, conductors and semiconductors. Choose the only false statement from the following. Choose the only false statement from the following. See the options na. Choose the only false statement from the following. Adillamma illige bomba idu
ಇಲ್ಲ ಸರ್, ನಮಗೆ ಫಸ್ಟ್ ಇಂದ ಇರೋದೇ ಅದು.
ಹೌದಾ? ತೆಗೆದುಬಿಟ್ಟಿದ್ದಾರೆ. ಓಕೆ ಓಕೆ ಓಕೆ, ರೈಟ್. ರೈಟ್, ಓಕೆ, ಒಳ್ಳೇದಾಯ್ತು ಬಿಡಿ. ನಾನು ಅದಕ್ಕೆ ಅದು ಇದೆ ಅಂದ್ಕೊಂಡೆ, ಯಾಕಂದ್ರೆ ಇದು ರೈಟ್. ಓಕೆ ಓಕೆ, ನಿಮ್ಮದಲ್ಲಿ ಫಸ್ಟ್ ಕ್ವಶನೇ ತೊಗೊಳ್ಳಿ. ಓಕೆ, ಇಟ್ ಈಸ್ ಫಸ್ಟ್ ಕ್ವಶನ್ ಓನ್ಲಿ. ಅದನ್ನು ತೆಗೆದುಬಿಟ್ಟಿದ್ದಾರೆ. ಆ್ಯಕ್ಚುಲಿ ಇದರಲ್ಲಿ ಇತ್ತು ಮುಂಚೆ, ಸೊ ಅದು ಆಮೇಲೆ ಹೇಳಿದ್ಮೇಲೆ ತೆಗೆದಿದ್ದಾರೆ ಅದನ್ನ. ಸೊ ಯುವರ್ಸ್ ಇಸ್ ಫಸ್ಟ್ ಕ್ವಶನ್ ಓನ್ಲಿ, ರೈಟ್. ಸೊ ಫಸ್ಟ್ ಕ್ವಶನ್ ಈಸ್ ಚೂಸ್ ದ ಓನ್ಲಿ ಫಾಲ್ಸ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಫ್ರಮ್ ದ ಫಾಲೋಯಿಂಗ್. What is the false statement there? In conductors, the valence and conduction bands overlap. Is it correct? Is it correct? Correct. Substances with energy gap of order of 10 electron volt are insulators. Is it correct? Substances with energy gap of 10 electron volt are insulators. Na, that's correct na? Correct ah? Which is false statement anta kelta idare. The resistivity of semiconductor increases with increase in temperature. Resistivity decreases. So resistivity decreases with increase in temperature. So the conductivity of semiconductor increases with increase in temperature. conductivity of semiconductor increases with, it increases. Does it increase? The conductivity of a semiconductor, it increases. Correct now? Therefore, wrong statement is C. The resistivity of semiconductor increases a lot, it decreases. Okay. Next one. Carbon, silicon and germanium atoms have 4 valence electrons each. Their valence and conduction bands are separated by energy band gaps represented by Eg, Eg carbon, Eg silicon and Eg germanium respectively. Which one of the following relationships is true in their case? Energy gap. So, energy gap of carbon is more than energy gap of silicon is greater than Eg of germanium. Correct? This is what the correct answer. Option A. So, energy gap of carbon is greater than. So, akasmat idu option kelbodu. Okay, yakandre bari ade options barodilla, idu option barbodu. In case ee option illa alli, but only this na, these two are there. But this option might also be there. So, energy gap of carbon is more than the energy gap of silicon. Next one. In semiconductors at room temperature. In semiconductors at room temperature, the valence band is partially empty, conduction band is partially filled, the valence band is completely filled and conduction band is partially filled, valence band is completely filled, conduction band is completely empty. Which is the correct option? Option A. Valence band is partially empty. Partially empty. Andre it is partially filled alva. Correct? Huh? It is partially filled. Even conduction band is also partially filled. So therefore, it is option number E. Next one. Intrinsic semiconductor. Carbon and silicon both have same lattice structure, having 4 bonding electrons in each. However, carbon is insulator, whereas silicon is intrinsic semiconductor. This is because option number C. The 4 bonding electrons in case of carbon lie in the second orbit, whereas in the case of silicon they lie in the